Hello everyone. I am Reshmi, Assistant Professor, Computer Science Department, Ansar Women's College. Hope you all are fine at your home. Due to corona pandemic, we have locked down. But you should not allow this situation to lock down your studies and ambitions. So, we are starting our 5th sem classes in online mode. You must take advantage of this opportunity. This online classes will help us to cover syllabus on time. I am handling the paper named Computer Organization and Architecture. The main objective of the course is to learn how computers work, what are the basic principles of processing, how to analyze the performance of a computer, how computers designed and built, memory and IO device organization. I have already uploaded a video in your Google Classroom which introducing the course, syllabus, online class schedule and assessment methods to you. All of you please watch that video before attending this class. So, shall we start? Let us start with the first lecture. We will discuss Introduction to Digital Circuits. Digital circuits are the backbone of every modern day gadgets like computers, smartphones, etc. For a definition, we can say that digital circuits are the circuits that handle digital signals. So, what is a digital signals? Signals are of two types: analog signals and digital signals. Analog signal is a continuous signal that changes over a time period. Let us look the representation of analog signal. It is represented by a sine wave. At any particular point of time, you can find a particular value in the signal and the value continuously change. And the value is dependent on the time. Whereas in digital signals, it carries information in binary form. That is 0 and 1. This means it has only two possible values, 0 and 1, off or on, high and low. So the digital signal can represent using a square wave. Look at the graph given here. Time is plotted on the x-axis. Voltage is plotted on the y-axis. In analog signals, there is voltage is continuously varying dependent on the time. Digital signals are only ever on or off. Analog signals can be a voltage in between on and off. See this example. In analog signal, there is continuous flow of electricity. Take the example of this light. If I keep playing with the regulator, there is a continuous increase and decrease in the light of the bulb. This is the case of analog signals. Now look at this type switches. All of you are familiar with this type switch. It is similar to digital signal, where the signal have only two values, on or off. Now I hope you understand these two graphs. Now let us see the difference between digital signal and analog signal. The left hand side of the table deals with analog signals. We have already discussed that analog signal is a continuous signal that changes over a time period. What about digital signals? Digital signal is a discrete signal that carries information in binary form. It is difficult to analyze analog signals compared to digital signals. You have already seen analog signals are represented by using a sine wave, and a square wave is used to represent a digital signal. It is clear that analog signals contains huge number of values. Its value can be both positive and negative. But digital signals stays in a finite range. It can have the values either 0 or 1. Analog signals have more tendency to get distorted, but digital signals has a less tendency to get distorted. Analog signals requires an infinite memory for storage, whereas digital signals require less as it stores data in the form of binaries. These are the reasons for saying analog signals are not easy to handle. So nowadays all modern gadgets are using digital signals. Examples of analog signals: human speech, current, instantaneous voltage. And examples of digital signals are computers, optical drivers, and digital phones. So, what are the advantages of digital system? Let me conclude. What are the advantages of a digital system? Ease of programmability, reduction in cost of hardware, high speed, high reliability, design is easy, it requires less memory. I hope all of you are clear with the topic analog signals and digital signals. Now, I am moving to the next topic, positive logic and negative logic. There are two types of representations used in digital systems: positive logic and negative logic. The only thing that you keep in mind regarding positive logic is the higher the voltage level correspond to logic 1. The lower voltage correspond to logic 0. If you have 5 volt, it will correspond to logic 1, and 0 volt, it correspond to logic 0. I will explain once more. Look at the voltage levels. Here, there are two voltage levels, 0 volt and 5 volt. The higher value is 5 volt here. So, in positive logic, the higher voltage value correspond to logic 1. Hence, the voltage 5 correspond to logic 1. And the lower voltage 0 volt correspond to logic 0. Here, bit 1 is assigned to logic high and bit 0 assigned to logic low. A circuit requires logic 1 to operate. Positive logic is the most common type of logic. In case of negative logic, everything is reversed. If you have the high voltage, then it will correspond to logic 0. Here the high voltage is 5 volt. It is correspond to logic 0. So we reverse the condition here. In the same way, low voltage is there, it is 0 volt, it is correspond to logic 1. So we can say that if we have 5 volt in negative logic, it will be represented as logic 0 because this is the higher value. And if you have 0 volt, it will represented as logic 1. In negative logic, bit 1 represents logic low and bit 0 represents logic high. A circuit requires logic 0 for operation. Let's have another example. In this example, we have logic 0. This corresponds to minus 5 volt and logic 1 corresponds to 0 volt. Can you find out what type of logic it is? Is it positive logic or negative logic? For solving this, you have to find out the greater value. Here the greater value is 0 volt. 0 volt is greater than minus 5. The higher value is assigned to logic 1 here. That is, the greater value is 0 volt and the 0 volt is assigned to logic 1. That is, greater value or higher value is assigned to logic 1. That means this is positive logic. Right? I hope you will all know the difference between positive logic and negative logic. So, thank you all. We will see on another class with next topic.